Okay guys, so let's continue. So what we will be doing in this one, as promised, we will be configuring ISP, and we will be configuring some addresses, some loopbacks, so that it shows that it's an ISP, right? So if I go to ISP1, right now we do not have any address configured, right? Nothing is being done on this device. So my first task is to make sure that the IP addressing is done first, right? So that's what I'm gonna do. So let's go into one of the interfaces. So we're starting with 0 by 0 and put the proper IP address. So I would say 13.3, 255.255.0, and I will do no shut. And then I will go to 0 by 0, sorry, 0 by 1, and I will do IP address 134.325.255.0, no shut, and then I will do 0 by 2. So this is what we have decided, right? So ISP is saying that, oh, okay, right now there's no branch exist, but I think this is what we are gonna give if there's any branch, you know, because we decided that 192.136.325.255. So this is our ISP. So we have done all the interfaces. Now we'll create some loopbacks. So let's say we create 3.3.3.3, and then we create 33.3. So some addresses, some couple of addresses, just to simulate the ISP, like if it wants to go, right? So I'm not doing anything else, right? I'm not going to do anything else. I'm going to say right, nothing. I'm not going to do anything on this device yet. I will go to ISP2 and I will do the same, like interface 0 by 0, 192.124.4, 0 by 1. So this is 34.4, then 0 by 2. This is 46.4, so I'm just changing it, and then 0 by 3, which is 47, and then I will create two loopbacks. One is 4.4.4.4, and one is 44.44, just to demonstrate that we have the internet. So if I look at now, I have a couple of physical interfaces, and then a couple of logical interfaces which are simulating an internet environment, right? So now let's move on. And right now there is no connectivity of any kind of protocol between ISP1 and ISP2, which is fine. We'll do that later. So what I want to do right now, that on headquarter 1, I have to make sure that he has a default route pointing towards an ISP. This is fine, right? So we can go here and we will say IP route. We need a default route towards 192.1.13.3, right? But we do not have the IP setup on our interface Ethernet 0 by 0, so I have to do the IP address setup, right? So I did two things. I set up a default route towards the ISP, and I also set up my interface. So by doing this, now if I want to ping 3.3.3.3, I can ping, right? And if I want to ping 33, I can ping. So it means that my headquarter is now connected to ISP, right? No problem, no issues. My headquarter is going to ISPs. So if I go to headquarter 2 and I do the same thing, 0 by 0, IP address 192.124.2.255.255.255.0, no shut, and then I will say IP route, default route pointing towards 192.124.4, right? By doing this, if I ping 4.4.4, I have the internet access, right? But I do not have internet access, complete internet access, because if I'm pointing towards ISP should take me to 3.3 as well. So if I ping, it's not going anywhere because it doesn't know. ISP doesn't know about it, right? So we need to fix that issue. So how we fix that? So first we have to fix the ISP issue, then we'll fix the LAN issue. So we will run BGP between ISP1 and ISP2, right? So we'll say config router BGP3, so it's a public domain, and then we'll say neighbor. And who's the neighbor? Neighbor is, let's say, 192.134.4 with the remote AS of 4. Simple. We're going to keep it simple, right? I'm not going to complicate things here. And then we'll do network commands. I can say connected to them, that okay, these are all connected, which is fine. But I can do both ways, right? So let's do network command. So I can say via network that I have 4.4 with a mask of 255.255.255.255. So I have this guy, right? And then I have 44.44.44.44. Oh, sorry, I'm on ISP1. Should not be this one. Sorry, it should be 3. Right? So let's do it again. 3.0.0.3, and then 33.33.33.3. So if I keep it that way, right, and I don't do anything else, right? So this is what I run here. So run section router BGP. I created a neighbor, and to that neighbor I advertise my 2 loopbacks. So if I go to my SP2 and I say okay, IP LB4, and then I have a neighbor with the remote AS of 3, and then I will advertise him these guys and this guy, right? So if I look at my BGP table, I have 3, right? I have 3 and I have 33. So what do you think? Can my headquarter 2 now reach 3? The answer is no, it won't. But is ISP receiving it? That's what we can test, right? We have a debug IP ICMP. If we go back, if we do this, go back to SP1, yes, he's receiving it. So it means that he doesn't know how to go back to headquarter 2, right? So because I'm not advertising anything else. So for that reason, what I will do, I will redistribute my connected routes onto the to my ISP2 and vice versa, right? So I will create a route map. So let's create a route map. The reason I'm creating a route map because I do not want to advertise the loopbacks. I don't want to advertise them because I already advertised them, right? So I want to exclude them. So I'm going to create a route map, connect it, right? And I will match interface. In this case, I will match Ethernet 0 by 0, Ethernet 0 by 2, and Ethernet 0 by 3. Right, and then I will go into router BGP3 and I will say redistribute connected with the route map con. So this is what I did. So when I did this, if I go on ISP2 and if I look at QIP BGP, now he has 13, he knows about 35, he knows about 36, whatever the routes, the networks are about, he knows about it. So for my ISP2, I can do the same thing. Route map con. And then I will say match interface Ethernet 0 by 0, Ethernet 0 by 2, and Ethernet 0 by 3. And then I will say router BGP4 redistribute connected with route map con. So now they know. So now if I go to headquarter 2 and I say, hey, I want to go to 3, hey, there you go. I can go to 3, right? So if I go to headquarter 1 and say, hey, I want to go to 44. So I want to go to 44. They say, yes, you can go to 44. It's on internet, right? So now it seems like it's huge internet and I can reach these sites. But can my PC go to the internet? So if I go to ping 3.3.3, can I go to 3.3? So the answer is no. Now, is ISP receiving it? Yes, ISP is receiving it, right? So it means that ISP doesn't know how to go back. But in this case, ISP cannot go back to your private IP. It needs to have a public IP. Usually, ISP has an access list or IP prefix list which block any request coming from the private site. So they don't even accept it. In this case, you are seeing it as coming in and it's trying to respond. You will never try to respond and drop it simply. But in our case, what we will be doing, we will be doing netting on headquarter 1 and we'll be doing netting on headquarter 2. It's important, right? Because both routers need to do netting, because one is good for VLAN 10 and the other one is good for VLAN 20. So now from the ISP perspective, we are good. We have no issues, we are fine. The only thing now we are missing is that our LAN cannot reach the internet. It's still no branches except one branch, right, which is Metro Ethernet, directly connected. No remote branches yet, right? So I haven't added anything, and that's what I want you to think about, that how you build the organization, right? You build it piece by piece. Now let's move on. Now if you go on and look at headquarter 1, we want to do the netting here, right? And so let's go to headquarter 1. So the net is a two-step process. You have to create an access list, right? And then you have to have a NAT statement, and then on the interface you have to have you have to define which is the inside interface and which is the outside interface, right? So let's continue here. So in this case, we need an access list. Let's say access list 1, and before you create any access list, you verify, do we have any access list here? Right now we don't have, right? So access list 1, and we permit 10.1, 10.0, and we also permit 20, because these are our LAN, right, so far, and we have 30. This is our LAN, 10, 20, and 30, and that's what we did. Now if you do IP NAT inside, and then we do source, because they are doing mostly source, and then we have list, and the list is 1, and then we have interface, and the interface we want to go out is our public interface, Ethernet 050. So we'll say interface 050. So this is our NAT statement, right? So our NAT statement is fine. Now we have to go into Ethernet 0x1, and we have to say IP NAT inside, and then we have to go to 0x0, and we have to say IP NAT outside, right? So if I do show IP NAT translations, right now we don't have any translations, but if I go to VLAN 10 and ping 3, it's still not working. So what's wrong? Let's go back to headquarter 1 and see, do we have any translations? There's no translations, so we are missing something, right? So we will figure it out, that what we are missing. Did I create access list 1? Yeah. So let's see, show access list 1. There's no hit. Show an access list. This one doesn't show, right? Okay. So let's move on to show IP access list 1. So right now I don't see any hit, right? So why I'm not seeing any hit? So answer is very simple, because I put my inside in the wrong place. Ethernet 0x1 is not my inside, right? Why Ethernet 0x1 is not my inside? Because I have sub interfaces. So if I look at now, these things very easy to skip, right? Very easy to skip. I have sub interfaces which I have to define, not the main interface. So it means that I have to go into 0 by 1, and I say no IPNAT inside, and I have to go 0 by 1.10, and I have to say IPNAT inside, and the same I have to do on 20, and then I have to do 30. Okay, so IPNAT translation, nothing. Now if I go to, there you go, now it's pinging. So now if I go to 1 and I say, can I see my translation, there you go. So now my PC can go to, but what about 2? Can this guy ping 4.4.4.4? No, he can't, because his default gateway is 254, which is 20.254, which is router 2, and router 2 doesn't have any netting. So we go to router 2, we say, okay, we have to do the same thing here. So we have to, we can copy paste it or we can create it. So first of all, do show run include access. So we verify there's no access list, and then we do access list 1 permit 10.0 0, then we have 20, and then we have 30. Okay, and then we move on to our NAT statement, which is IPNAT inside source list 1, and then interface Ethernet 0 by 0. Now if you look at this statement, if I do show run include NAT, you see that overload is automatically added. That's why I didn't put it there. But if you are using anything, if you are using 12x version of code, OS code in Cisco, then you need to put the overload command as well. Now let's move on to Ethernet 0 by 1.10 IP NAT inside, then 20, and then 30. Okay, so now we have this. Oh, one thing missing. Ethernet 0 by 0 is IPNAT outside. We define the inside, we have to define the outside. So I'm writing it down. So let's go to VLAN 20, and let's say, can you take me to 4? I say, yes, I can take you to 4. And then it will ask, can I go to 3? Can I go to 3? And yes, you can go to 3. So you see now the public IP addressing. So now we have internet access. This is true for headquarter 3. So headquarter 3 wants to go to, is this true for headquarter 3? Let's say headquarter 3 wants to go to 3, and it can't, because headquarter 3 doesn't have any default route. So you see, headquarter 3 doesn't have a default route. And what we are running here, if you look at show IP OSPF neighbor, we are running OSPF between 2 and 3. So somehow these routers have to tell headquarter 3 the default route going out to the internet. Right? Somehow they have to tell him that how to reach to the internet. Right? If they want to. Right? And the reason they want to, because what if branch wants to go to the internet through the headquarters? So they have to do that, right? So what can be done here? We need to either we do it on both or on one. We have to figure it out. So just give me a second, let me have a water, and then we'll continue on this one. Okay, so we are back. So what we can do in this case, we can say we will go into the OSPF process, and we say default information originate, and then we can say, now this will happen if we have a default route. Right? If we have a default route, if I do this, so distribute a default route. Okay, now if we distribute a default route, only if we have a default route. If you don't have a default route, it won't do that. So if you want to do advertise a default route, whether you have a route or not, then you have to do always. So in our case, because we have a default route, and if for some reason we lose it, we do not want to advertise it, so we will just keep it that way. Now when I do this, router 3 should receive an external default route, right? And now if headquarter 2 does the same thing, default information originate, router 3 will have 2, right? Now because router 3 has it, branch 4 should have it. And there you go, he also has the default. So it means that, can this guy go to the internet? That's what we need to know. Headquarter 3 can. So if I go to 4.4.4, he can. If he goes to, and let me do undebug all, right? And then if I go to 3, it can go out. So this is fine, right? But what about branch 4? Now if I ping, this guy can't go out. Right? This guy can't go out. And does this guy need to go out? No, right? Who needs to go out? The LAN behind it, right? So it means that the source should be loopback 0, or the source should be loopback 1, which is the LAN simulated LAN, right? So what we need to do, that when the traffic comes from here, we have to include those networks in our net. So we have to go on to headquarter 1, and the only thing we need to do is that we need to create, we need to add in access list 1 permit 10.1.8.0 and 88. Now if you look at access list, just added that, right? And sometimes you have to make sure that it's in the right place. And for this map, I will just copy it here as well. Okay, so now if I go to branch 4, means I want to go, you can go back 1, you can. But if he doesn't apply any interface, this interface cannot go to internet, right? Because we are not advertising, there's no need of it, right? So only the LAN is going out to the internet, and that's fine. So it means that branch 4 has a proper internet access. It means that the whole headquarter, including the Metro Ethernet branch, can go out to the internet. Because in our case, branch 4 doesn't have its own internet, right? So it's using the headquarter internet to go out. Can branch 4 go to 3.3.3? We can't go with Ethernet 0x1 as a source. So to do that, we have to change our source. Yes, change our source. Yes, it can go. Now if you trace how it's going, 10.1 with the source of loopback 0, you can see that it's going to 9, which is headquarter 3 IP. Then it's going to 30.2, which is headquarter 2, and then it's going to 4, which is this guy, and then it's going to 3, which is this guy. So it's taking this path. If I do 4, and it's going the same path, right? Now let's do the same thing, but with 33. It's going the same, 9, 2, 4, 3. So this guy is taking this path because headquarter, if I do show IP route in there, and show IP SAF 0.0, which is CVIT. So if I do show IP SAF, and you can check that which path it will take. Show IP SAF exact route, and then you say what is your source address. So let's say my source address is 10.1.8.8, and my destination address is 3.3.3.3, and there's no port. So it's telling me that okay, if this comes in, I will send it to 30.2. Now if I change the source, it it says I'm still going to send it to. So at some point you will see that it will change, but it's in load sharing, right? So it will change at some point it will change. So well, we don't mind any way around, right? Because if we, for example, if we go here and we shut down Ethernet 0 by don't shut down here. Let's do, because everything's going towards router 2, so that would be a better test. If we go there and we shut down this guy, so we shut it down, right? So once we shut it down, router 3 will lose 1, and branch 4 can still, if you do if you do the trace to 4, and now it's going to 30.1, which is router 1, then there, and then there. And if we do 33, now it's going directly to 1 and 3, right? Because that's how redundancy we made, right? But in our case, what happened that VLAN 20 can go, no issues. And let's go to 4, it can go, right? And if you look at show standby brief, this is happening fine. But if I go to headquarters 2 and look at do show IP route, you can see that now I have a default route from router 1. See, that is why it's working. And because I have the default route, what's happening that if I do a trace, it will first go just the trace. I forget all the time. So if you first go to 2, then you go to 1, and then you go there. So if you want to say this you don't want this to happen, what you can do, you can track, right? You can track. So if you go on to interface Ethernet 0 by 1.20 and you say standby 20, and then you say tracked. Okay, so it doesn't give you the interface. Tracked 1, decrement, let's say by 30. Okay, and then you can track that interface. So if I go into the, can I do track 1 interface, and the interface I want to track is Ethernet 0 by 0, and I want to check line protocol. Right, so you see now it changed. So now if I go to VLAN 20, now it won't go to 2 at all until router 2 this interface come back up. So once it's come back up, then it will go to 2, right? So this is how things are going to roll. I can do the same here. So I can say config t, and I should do the same for both guys. I can say for interface Ethernet 0 by 1.10 track 1, not track 1, so standby 10 track 1 and decrement by 30. Right, so every time something happens to this, they will decrement. So I will do track 1 interface 0 by 0 9 protocol. Right, so what happens is that every time this goes down, because he's the parent or the active for VLAN 10, he will say, okay, because this is down, I'm gonna remove myself from active and I will ask router 2 to become active. That's what it's going to do. Okay, so this is what we did. So if you look at show1 interface 0 by 1.10, so we just added this line. And if you look at show1 include track, so if I have to track completely, we put this line, because this line is from this interface. Okay, So this is how we have set it up. So now everything is working fine. Our headquarter is configured, there's no issue, and it's almost 30 minutes. I'm going to stop it here, and then the next section we will start building our branch offices which are connected to the ISP. Thank you. Have a good one. Bye.